So here we have another system of equations that we want to solve. And it tells us to use the addition method. So um, they're not in the right form. They're not in that ax plus by equals c form. So we need to get stuff, lined up, get it in the right place. I need the 7y to come over there. So I'm going to come down here and write 2x minus 7y. When it goes to the other side, it's going to change its sign. And that's going to equal a negative 17. Now I want to make sure I write negative 17, right? Okay. And then it looks like this minus 3x is going to have to go to the other side, but now it'll be positive. So it'll be 3x plus 5y equals 17. Okay. Well, now at least they're in the right form. So I want to get either the x's to eliminate or the y's to eliminate. Now, I'm going to choose the y's. Now, some of you might say, well, I'd rather choose the x's because they're smaller numbers. And you have a good point. We could do it that way. But I'm going to go with the y's because one's already positive and one's negative. Okay, so that's why I'm going to do it that way. So I'm thinking of a number that both 7 and 5 go into. It's like finding a common denominator, right? 35. But remember, I need one to be negative and one to be positive. Okay, if I multiply the top equation by 5, that'll get me a negative 35. Yay. And if I multiply the bottom equation by 7, then that'll get me the positive 35. And then I'll have the y's eliminating and I'll be very happy. Okay, so you're allowed to do that. You have an equation. You can multiply by whatever you want, as long as you multiply it on both sides and it's not 0. And the other equation, it's a separate equation, so you can multiply by a different number. That's what we're doing. Okay, so I usually make like a little arrow thing to say, all right, what do I get when I do all this distributing? And I'm not going to keep drawing those arches because they're going to get in my way, but here I get 10x minus 35y equals negative, let's see, 85. I really need to go get my calculator. Okay. Okay, so now I'm going to multiply the bottom equation by 7. So I'm going to get 21x plus 35y. Now that's really exciting because I have a negative 35 and a positive 35y, and those are going to eliminate. All right, so I did that. Then I got to multiply 7 times 17, which is, I went and got my calculator, 119. All right. These are going to, when we add them together, we're going to get the y's to eliminate. All right, 10x and 21x is going to be 31x. These eliminate, yay. And then what's negative 85 and 119? Good thing I have my calculator handy. 34? Okay. Now, that doesn't look super friendly right now, but that's okay. I'm solving for x. Divide by 31. And I get x equals 34 over 31. Now, that is a fraction. Fractions are our friends. It just means it's not an integer. It's okay. It's a lovely answer. It's just not maybe the most convenient to always work with, but it's what x is. Okay, it's not going to simplify. 31's prime. 31 doesn't go into 34, so I'm just going to leave it as an improper fraction. That's the best way to leave it right there. Okay. But how do we solve for y? You could take and substitute it in, but you're going to get into this kind of fraction world where you got to get common denominators and multiply by reciprocals and things like that. So a way to avoid all the fraction work is to go back to the original, not the original, but where we had them in the right order. So go back to 2x minus 7y equals negative 17, and then the 3x plus 5y equaling 17, and then eliminate the x's this time. Okay, but this is a good example for me to show you this to you anyway. So how do I eliminate the x's? So I have to think about, what do both 2 and 3 go into? Well, they both go into 6. So that's like the LCD, the least common denominator, or the least common multiple of 2 and 3 is 6. Okay, but I need one of them to be positive and one of them to be negative. Now, it doesn't really matter which one you make negative and which one you make positive. I'm going to make the top one negative So I'm going to multiply by -3. And I'm going to make the bottom one positive. Sometimes I do that just so I don't forget. So I do the negative on the top one. But you could have easily done the negative on the bottom one, and there might be a reason to do that. Okay. But I already have negative signs up there in the top equation, so some of those are going to eliminate now. So I distribute, I get -6x plus 21y equals 3 times 17, I think, is 51. All right. And then the bottom equation, I'm going to distribute here, and I get 6x plus 10y equals 2 times 17 is what, 34? Okay. And then I can add those together. Now look at the x's. They eliminate because I have a -6x and a +6x. A common mistake here is people don't make one of them negative. They have 6x and 6x. That doesn't cancel. 6x and 6x, that makes 12x, not 0. So you have to make sure one's negative and one's positive. Okay, but we did. All right, 21y and 10y is 31y. Now, when we get that same coefficient, it's a comfort. It doesn't always happen, but 51 and 34 is 85. And then I'm going to divide both sides by 31. And y equals 85 over 31. Now, the fact that the denominators are the same, like I said, that's kind of a comfort. It comes from other math that we're not going to do this semester, but it's really cool math. Okay, so we have x up here and we have y. We're going to write it as an ordered pair. So it's 34 over 31, comma, 85 over 31. So we're kind of used to integer answers, but not this time. There are these crazy fractions, and that's what the answer is. So we just have to say when we do it in MyLab and we get the little green check, we'll just be happy and excited.